All right, well, this is our last 224 class.
Kind of sad.
Kind of sad.
Yeah.
What?
Went by fast.
It went by fast, yeah. It seriously did. But it's good. I think people are in good shape for 222, and that's kind of the point of this class, is to get you ready for like future classes, both 222 here, but then also stuff that you do at Wazoo if you're heading to Wazoo, or somewhere else where you're going to be Unix focused. This stuff will definitely help. So hopefully it's good prep. So so questions before we just kind of keep going through the review. Yeah.
I just noticed something on the list of possible topics.
Yeah.
It talks about comments hashtag include with the angle bracket, with the arrows, and hashtag include with quotation marks.
Oh yeah.
There's a difference.
There is a difference. So normally, in the top of your programs, we say something like this. And it magically pulls in declarations for printf and scanf and all that other stuff. But sometimes when you're writing your own program and you're modularizing and splitting into different files, you have your own .h, and you want to include that, and that you do with something like this.
So quotation marks are for the informal .h's.
Yeah, quotation marks are for the stuff that's usually in your current directory. And stdio.h is not in your directory. It comes from a system directory. The angle brackets tell it that this is not a file in my directory. This should come from somewhere else. And usually where these things come from is /user/include. So if you include something with angle brackets, it's coming from this directory.
So if it's another library from a different directory, you still use quotation marks instead?
You can always use quotation marks. You could say quote /user/include /standardIO.h, and that would work perfectly.
Oh, okay.
But if you use angle brackets, it's the same as doing /user/include. So all of these things are includable, and there's standardIO.h up here, and standardlib and string.h, and math should be in here, and so on and so forth. There's also directories in here, like sys. So sys is a directory, and it's got its own stuff in there. Well, it's got one thing in there. So you could include angle bracket sys / blah blah blah. So the angle brackets basically just say go ahead and put /user/include in front of whatever I specified here. And just saves you from having to type that time and time again. And you can also change what that defaults to. But usually it's user include. Yeah.
You might have already answered this yesterday, but how many questions will be on the file, and are there multiple choices? And
So 5 programming questions, 10 points each. And then I think it's 20 or 30 short answer questions, a couple of points each.
5 program and 3C program or 2C program.
I don't remember. And I'm not going to look it up this time.
Did you say 20 short answer?
20 or 30 short answer, yeah. 50 points worth of short answer, 50 points worth of programming.
Quite a few.
It is. And I usually intend those to be, a fairly straightforward opportunity to just show that you understand Unix stuff. But sometimes people get really worked up over these, so try not to get worked up over them. There aren't a whole lot of trick questions that I ask in general, right? So they're usually pretty straightforward. Show me a command for renaming this file to that. Right? There's no trick there, just write the command. Stuff like that. But they come from, all of these areas about Linux. So theoretically there's a lot, but you've been doing this stuff like 11 weeks here and through 121 and so on. So you know a lot about Linux, even if it doesn't necessarily feel that way to you.
I have a
Yeah.
Can you explain again the SD for F open?
Sure. So let's do it here, and then we can do some code. So when we do fgets, normally we give it a string, we give it a length of the string, and then we say standard in. Right? This can be something other than just standard in. Right? Standard in means read from the keyboard or a file if we're redirecting, or the output of a command if we're piping. But this can be something more general, which we can call a file descriptor. That may be more my term than an official term. And file descriptors have a type file star, file uppercase.
You have to open that file beforehand?
Yes, you do. So file star, usually I just call it FP for like file pointer. And we can create a valid file pointer using fopen.
Does that mean you can point to a spot in the file first and then send it in there?
You can do seeks actually.
Okay.
So you can open a file and then you can like say seek down this many bytes. I've never actually done that because it always feels like it's more quirkiness than I want to deal with.
I was just thinking about like parsing a file that way.
Yeah. And you can go backwards, you can rewind, you can do all kinds of stuff. But I'm a Neanderthal, so I always try to do it myself. So yeah, fopen takes a file name, right? So it's a string. It can be a string in quotation marks, or it could be a char star character array. But some kind of string that says the name of the file, and then usually you say quote R if you want to read, or quote W if you want to write. And that returns a file pointer, right? A pointer to this type file. And then you can take that FP and you can use that inside fgets. Or you could use it as the first argument of fprintf. Alright, so fopen basically tells you all of that. fopen returns a file star, takes a path name, and it takes a mode. So your mode is usually R or W for read or write, but there's other options as well. R plus will do reading and writing. W plus will append.
W by itself deletes everything before it writes,
W deletes everything before it writes.
but R plus wouldn't.
A will not. A will start appending at the end of the file. W plus will create the file if it doesn't exist, otherwise it truncates it. So those both zero out the file.
R plus and W plus is same.
R plus is for reading and writing. Oh yeah, W plus is reading and writing too. W plus truncates the file to begin with. R plus does not. To zero length. But as you're writing it, you can also read. So you can go backwards and forwards. So you can do fseek to move around, and let's find the C also. Yeah, it doesn't talk much about C. It's always good when there's a section of bugs too. Alright, so that'll open a file called haha. It'll truncate it if it exists. It'll write one line into it which says this is weird, and then it will exit. Technically, we should be nice and close our file when we're done, but it'll close when your program exits anyway. Right, so it makes a file for you. stdio.h is pretty painful to go through because it's 870 lines and half of it is including other things. But I'm guessing the setup for a file type might be inside bit/type/file.h, maybe.
The structure,
Is it?
isn't it? So,
I don't even have a bits. Yeah, so I don't know. I can never find things when I try to run them down like that. But somewhere in that path from user include stdio on down, file is defined.
Can you say fclose file name in the end of your file program?
So you say fclose and the name of the file descriptor, so fp in this case. Right, use the file name when you do the fopen, and after that everything's done with fp, the file pointer returned by fopen. And sometimes you'll segfault when you do this. You can segfault when you do anything. Because if you look at the value of fp, ignore the warning. Right, sometimes fp comes back and it's 0, it's actually null. So usually after you do an fopen, you want to see if fp is equal to null. And that'll tell you that something went wrong with the open statement. Alright, and what's going wrong here is I'm trying to open a file under / and I don't have permission to write into that directory. Whereas if I just open haha, that's coming from my current directory. That should work fine. Other questions? This is good.
On the midterm, we had a question about scanf, and we had to like return different values based on like what was put in for a command line.
Mm-hmm.
And I've been doing this weird thing to check whether, so if you do scanf and you give it nonsense, it returns a 0. So I like was doing this thing to check if scanf was nonsense, and what was input for scanf was 0.
Mm-hmm.
And you wrote a note about using the return value of scanf.
Yeah.
Whether that's 0. Do you go over there?
Yeah, definitely, because you definitely want to be good with scanf for the exam. Okay, so let's just do some test code. So we'll prompt the user, we'll read in one line of characters stored in a variable called str, and then we'll use scanf. And we'll try to scan as 2 integers, and we'll store those integers in I and j. And I'm going to save the return value from scanf into this thing called retrun value, return value. then I'm going to print out those variables. And we'll just play around with scanf like this. Okay, so I can enter 23 and 45. I equals 23, j equals 45, return value equals 2. I forgot my new line. All right, so type in absolute gibberish, right? And I and j happen to be 0, but that's not significant. What's significant is the return value from scanf was 0, right? And I and j being 0 is not significant because I and j might have values from some previous call to scanf, for example. And if I do my scanf, it looks like I got 100 minus 45, right? But those values of I and j are meaningless because the return value from scanf was 0, which tells me it loaded 0 variables, right? So if I run this and I put in 77, right, it tells me our return value is 1. I got 1 variable back. That's I, right? 56, I get a 0 back. It tells me it loaded 0 variables, right? It gives up as soon as it can't parse according to whatever our parsing string is going from left to right. If I only put in 1 number, it will pick that up with the first %d. It will fail on the second one. It'll return a value of 1. Tells me I got 1 number. So if my goal is to get 2 integers, the only thing I got to check is the return value equal to 2, right? If there's more stuff on there, that's okay. I only asked it to parse 2 integers. It did. It gave me a return value of 2. If my line is empty, it gives me a return value of -1. Right, so I might fail with a return of 0 or -1 or +1. Right, so it's easier to check for success. Make sure it's equal to 2. If it's not, something went wrong. That make sense?
Mm-hmm.
Okay.
Thank you.
Yeah, thanks for asking that one.
With 100 and -45, the integer, so why is return -1?
Because I asked it to parse an empty line,
Oh yeah.
right? So I just hit return there, so it couldn't find an integer.
So the scan basically converts the character to integer.
It's trying to convert a totally empty line into 2 integers, and there's nothing on that line, so there's definitely not 2 integers. So it does not return 2. It didn't find 1 integer. It does not return 1. Right, so normally we return 0, but in this case the line was actually totally empty, and so it returns -1. It's just an extra flag. I don't know if it actually talks about that. On success, these functions return the number of items successfully matched and assigned. Value of EOF is returned if the end of input is reached before either the first successful conversion or a matching failure occurs. So it's actually returning EOF, which is -1.
Is there a way to make scanf work for anything?
Like what?
Like the third line there, you have 56, 78, and then blah, 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 blah. Is there a way to set it so if it finds anything there, it's considered a success?
Yeah, I mean, you could parse with a %s.
That's great.
Yeah, and that'll go up through until you hit a space. But %s is dangerous in the way that gets is dangerous, because the string that you load into, you can't specify a length for that. And so if someone puts in 1,000,000 characters without a space, it'll take all of that and try to load it into your string, and you'll probably overflow that section of memory. But it gets a little trickier, but you could go into your original string and find your way to the end of the second number and then just build a new string that starts there and goes to the end or something. But scanf is fairly rudimentary in some ways. I think that's one of the ways.
Okay.
All right. Other questions?
Can you go through accessing arrays in that?
It's not going to be on the exam. But if you do that, let's see if I can get this right. I probably won't. Hey, I got it right. And there's some kind of wildcard you can use that will, I don't remember what the wildcard is. There's something you can put in here that'll give you all of the, oh no, we don't have to because it's not associative. Yeah. But I'm not going to ask you arrays or associative arrays. Well, let's see, where do we leave off? Zenity, GCC, so you know how to use GCC, right? GCC-C compiles but doesn't link, so it leaves you a .o file. And we typically use that inside makefiles, which come after GDB. So GDB, what do you want to know from GDB? Know how to compile. Right, you have to include a -G switch somewhere so that when you're inside GDB it has access to your variable names and your source code and so on. When you want to right, so we'll call our executable program stuff, and you list your files you want to put in there. When you want to actually debug, you say GDB stuff. That starts the debugger and it prompts you for what you want to do. And you can list your code, you can set breakpoints and so on, but usually the first thing you do is you say start. And that'll get the process rolling, but it'll usually stop and say, okay, I put a temporary breakpoint at the beginning, and now you can do any of the following. You can say break at some location, which can be a line number, it can be the name of a function, it can be some simple arithmetic, I believe. You can say print, you can say list. I don't think we got to play around with watch points, so I don't have watch points on the exam, but you can say watch variable name, and it will tell you whenever a variable changes value. That's really useful, right? You're setting some variable to the length of your dictionary, and it keeps going back to 0, and you don't know why. Put a watch point on it, and run your code. As soon as that variable changes value, it'll tell you, and it'll come back to you, get your attention, and you can figure out what's going on. But we didn't really play with that.
Is print and list just like print a variable or list a variable?
Print is a variable, list is a line number. So list is looking at your source code. Print is actually printing the value of a variable, interpreted as whatever kind of variable that is. X is looking at a memory location. So you're just kind of looking at bare memory in different formats.
For like stuff like GDB, do you care if like multiple commands do the same thing? Do you care if you use a different command?
If you got your own favorite command and it does the same thing, that's fine.
Okay.
Yeah.
So will there be a question about sending your watch point?
No, that's what I put in parentheses, so you don't have to know watches for the exam, because I don't think we really played with them. But you know how to do breaks and prints and list and examine and continue, which says keep running from where we are until you hit a breakpoint or something stops your program. And if you don't want to just free run, if you want to go one line at a time, your two options are next and step. Right, so next is like a step over, and step is a step into, in 270 MP lab terminology. So step goes inside a function, starts debugging that function. Next, we'll execute the whole function and then come back. So if you're about to do a printf, do a next. If you're about to call your function that you want to debug, do a step. I think that's probably all you need for GDB for this. And really, that's like, 90-95% of what you'll use when you're debugging a program. Right, that and going back and looking at your code again and again and writing down notes. Make files. So I might ask you to sketch a make file, or I might give you a make file and ask you what it does. So remember, make files are these text files with pairs of lines. There's a target, colon, dependencies, and then there's a tab and a recipe. And those get repeated. So if you say make, it looks for the first target and it wants to build that. If you say make blah, it looks for a target named blah and wants to build that. And for whatever it's trying to build, it looks at all the files that it depends on, and it makes sure that those are up to date. And if they are, then it executes the recipe, which is usually something like a GCC command, but it could be anything.
So I ran into some problem when I was doing this,
Mm-hmm.
and I would change one of my source files and run make, and it would say everything was still up to date.
So probably you didn't have a dependency somewhere that you needed it.
Yeah.
So typically you'd see something like this: main depends on main.o and function.o, and then there's your GCC line. Main depends on main.c, and there's your GCC line, and so on. And so if I change my function, when I say make, it'll try to make main. It will say is function.o up to date. Well, it'll look and say function.o depends on function.c. Function.c is newer than function.o, so it'll perform this recipe, right? So you can technically just use a make file to wrap your GCC. You can make all of these depend on your .c files, and then just have a big long GCC line. And that works, but it's not really capturing what a make file does, because if I change function.c, it's going to recompile main.c as well. So this sort of breaks it into pieces. But yeah, if you update a file and it's not remaking, it's probably a dependency that's missing. So you have a make file, it's usually called this. But it can also be with a lowercase m. And then if you say make looks in your current directory for a file with this name. If it finds it, it goes through and it figures out how to build your target, and it executes all those commands from the recipe. So it's really easy once you got it set up. You just say make. tar you've been using for assignments. So 3 versions of tar that I've asked you to use: CVF, TVF, and XVF. So CVF says create a tar archive, a tape archive. TVF says show me the table of contents in a tar file, and XVF says extract from a tar file. Right, so this creates, this shows the contents, this pulls things out of it. Right, extract does not change the archive itself, it just copies the stuff out of it. The tar file is unchanged. And when you have this F here, that says the next file that I list is the name of the archive. So this is, archive.tar. And then you list all the files if you're trying to create files or extract files by name. But the F says the next thing is the name of the archive. So if that's main.c, main.c gets turned into a tar file, and your program's lost. Which everybody's done before, including me, and it's a pain. gzip and gunzip are just like zip and unzip. Right? You say gzip file and you get a .gz. And you say gunzip and you get rid of the gz, so there's not a whole lot to that. Regular expressions.
It's so hard. It's so hard.
Yeah. But I won't get really super hairy on you with it, right? So we've kind of only done a few types of things. We use a period to match any character, right? And character doesn't just mean letter, it's any character. We can use something like period star to say match 0 or more of these characters. So match 0 or more of whatever this thing is before the star. So 0 or more of any character. If we said bracket 0 through 9, that matches any digit. If we said bracket 0 through 9 star, that matches 0 or more digits. If we match 0 through 9 in brackets and then bracket 0 through 9 star, that matches any digit followed by 0 or more digits, right, which is basically any string of digits that includes at least one digit, right? So brackets match anything inside the brackets, stars match 0 or more if whatever comes right before, and you can put those together in whatever ways. Your anchors, say we have to match starting with the beginning of the input or going up to the end of the line. And you know, if you just have characters, they just match whatever characters. And I think that's it for things that match. I don't know if we did anything more. That's all I can think of. Basically things in brackets, periods, stars, anchors, and plain text. And then the substitution stuff, let's just put things inside parentheses. And whatever matches the stuff inside this parenthesis goes into this register 1 that we can access with \1. And if we had another thing, that would go into \2 and so on. And that's how we do things like match some pattern of characters, but then do something with those things that match. So reverse, you know, take the first 2 characters and the next 3 characters and swap them. All right, so go into the beginning of the line, match the first 2 characters, match the next 3 characters, and replace all of that with the stuff that matched those next 3 characters, followed by the stuff that matched the first 2 characters. That'll swap the first 2 and the second 3. So stuff like that.
Which utilities require you to escape the parentheses within stuff?
Yeah, I mean, I'm not going to take off if you forget to escape the parentheses, but if you're inside sed or VI, it wants backslashes. Most of the online regular expression exercisers don't take escapes on those. And, you know, that's at the level of syntax minutia that I'm not really worried about. But if you're going to do this, you got to put them in parentheses somehow.
Can you just go over quickly the functional difference between the 0 through 9 star and the 0 through 9 bracket, 0 through 9 bracket star? Do those actually give you any different values, or if
Yeah.
like, they just do the same thing?
Right, so if I just search for 0 through 9, I'm looking for any occurrence of a digit, right? Hello doesn't have a digit, hi to OK does, so it shows me hi to OK. If I search for 0 through 9 star, right, hello matches, because it contains 0 digits, right? And this also contains, you know, at least 0 digits, so that's going to match fine. So if I do this, right, I need a digit followed by any succession of digits, right? So hello doesn't match, but this will, right? And and that will also. So, in terms of matching, it doesn't really matter. That 0 through 9 star doesn't really do anything. But if we're doing substitution, yeah, let's just do it like this. So let's just substitute a digit followed by 0 or more digits with the word number. So regular strings come out the same. If I say hi 234 there, it says hi number there. Right? Okay, if I don't have that first 0 through 9, right, the empty string in the beginning matches 0 digits, and so it gets replaced with number. So putting that 0 through 9 before it forces there to be at least one digit. You can also do a plus sign, but
Hey, it didn't
or not. Okay, this is why I never use plus signs, because they don't work. There's something you can use.
They tried to match it in the beginning maybe, and it didn't see anything.
You should find it anywhere, even if it's not in the beginning. Okay, well, I don't know
So what's the
pluses.
plus sign do?
I don't know, that's why I never use it, but I thought I would be generous and offer it, but there is a way to do one or more occurrences, and I thought it was a plus sign, but
Yeah, it's definitely a plus sign in PCOE.
it is plus sign. Okay, so, well, but maybe SED doesn't like it. I don't know.
Maybe you have to escape the vector files.
Yeah, there you go. Well, that's even weirder than an asterisk, I think, then. Okay. This is why I learned like 3 ways to do things, and I just like to use those. So yeah, so that's pretty much all there is to regular expressions. Right, basic pattern matching, putting things in parentheses to throw them into registers, and then using / register number to replace. That's pretty much everything that we did. And then there's sed and awk. So sed, most of what we do is, we sort of talked about this a little yesterday. Right, probably our most common program is just substitute old with new. Don't forget your / at the end. But we can do other things. So we went through some basic commands like print and delete and insert and append and stuff like that. You can jot them down in the corner of your note sheet, but I'm not going to do anything too crazy. Probably this is sufficient. Substitute old with new. And then awk. Something like this. Let's just print fields from input. Right, so there's an awk program that prints the second column from each line. Spelled column wrong.
Why do we need to use -n with sed?
So with sed by default, reads from whatever the input is, and copies to standard out. And if you want to suppress that, you can use -n. So this reads from bash rc and it copies it to standard out. If I do a -n, then it doesn't do that by default. And so if I wanted to print lines that started with a comma, I could say caret number sign print. And now anything that matches an anchor at the beginning followed by a number sign will get printed, and that'll just print all the comments from my bash rc. If I suppress the -n, then it prints every line, but things that start with a comment get printed twice. So sometimes you want to suppress that default behavior, sometimes you don't.
Earlier when you were doing the regexes and you were doing the substitute command, when it found the line with a number, it only printed it once instead of twice. Is that because there wasn't the P after?
Was I doing the substitute like s/? So when you do s/, default behavior is to print every line, right, which it will, but I'm also doing some substitutions. Right, so that's just printing each line once, but it's also editing some lines. And on this one, if I did a -n, right, I wouldn't get anything. So when you're saying substitute /, you're actually executing a command. If you just say /, you're asking to match a pattern, and then it will print twice if I say print when it matches this pattern, unless I do a -n. That's a good one to mess with to get a feel for.
That's what the like /p at the end does though, is like if you did / and then substitute and then ended it with a /p, that's when it would print twice, right? Or if you did -d, it would just print nothing because you deleted it.
Right, so if I begin with a caret number sign, go ahead and print the line. Right, so that says print every line that matches, that starts with a comment. Right, but because I didn't do -n, it prints every line regardless, and then those lines get printed as well. Now if I say if you match this pattern, delete, right, then it'll just print the things that don't have comments.
I also wanted to ask about, so for our Zenity project, we said -i. I wanted to make sure that I understood what that did.
So sed -i basically says I want to replace the contents of the file. Right, and it will normally make a backup for you, so you can say sed -i and put in an extension, and it'll copy your file to filename.extension, and then it'll go ahead and edit the file in place.
Okay.
So without the -i, it's really reading from the file and writing the standard out.
Yeah, that's how I was treating it, but I wanted to make sure that I wasn't thinking. That it was
Yeah.
something.
Right, so there's a file, it's got 2 lines of code, and it's got 3 comments. Right, so this will pull out the lines that don't have comments because it'll delete the others, but it doesn't change the file. If I say -i, I believe that'll actually edit my test file. And I did not get a backup because I didn't say -i something. So you can put backup extension in there. And that's just nice because what you're trying to do with the reservation file was run a sed command on it and then put the output back into the reservation file, and it stops you from doing that by default. So this lets you do that. Let's see, bash programming, like I said, is exactly the same study topics as for the midterms, so know how to do all that stuff. right? So while loops, if then else's, variable assignment, read echo, algorithms. That's all. Entity's up here.
Okay, and the question.
Yeah.
So does entity have the match programming?
I wouldn't interpret it that strictly, but yeah, probably not. Do I really have auto scroll turned on?
Well, you have a question where entity is a programming in question?
That's what he was basically asking. I don't think so, but it shouldn't bother you if you do.
Yes, it does.
Okay, so C programming, so the main things that were new here was the file stuff, which we already talked about. And we talked about the includes.
What's flush and printf do again?
So fprintf is like printf, but it writes to a file. So you can say, you can do an fopen and get a resulting file pointer like fp, and then you can say fprintf, fp, comma, and then whatever you'd normally put into printf. And it prints into that file instead of to standard out. And printf is really just a wrapper around fprintf parentheses standard out, comma. So it's really just using fprintf. And fflush just forces your printed stuff to actually go to the output. So stuff gets buffered up normally and it doesn't actually appear until you close the file, which usually happens when your program exits, but you can force stuff to go out before then by saying fflush. We'll play with that more in spring in a Java version.
So it basically empties whatever you're piping into?
It empties the buffer, yeah, it dumps it out. And ctype.h might be new on here, so is space 2 upper, is lower. Those are good to know just because they can save you trouble, right? If I ask you to do something, to convert something to lowercase, you don't want to start messing with ASCII codes and subtracting 32 or adding 32 and so on and so forth. So you can just say 2 upper, 2 lower, and so on. And remember with those, right? They don't change this. They return the uppercase version of that character in this case. So you'd want something like C equals 2 upper C if you want to actually convert C to uppercase. Is alpha, is digit, those kinds of things just return a true or false, right? So they don't change the thing that you pass in either. And yeah, is space, is digit, all that stuff, you use that in PA4 and other stuff. And I think that's it. Everything else here was stuff that was on the midterm study guide. So, so suggestions if you want to prepare for this, right? Practice writing code, go over your coding, go over your ODPs, write code. Don't panic, don't freak out too much over this, right? There's no surprises, there's no, you know, I've got an evil plan to fail everybody, so I'm going to ask them to do such and such, right? It's fairly straightforward. You know, the biggest challenge is usually just the fact that you're in a room, everybody will show up, so it'll be crowded, and the clock's ticking, and you got an hour and 50 minutes, so it can feel freaky, right? And you don't have the compiler in front of you to check your syntax and stuff, but practice, you know, your programming assignments, your ODPs and stuff in that kind of context, right? Try writing out code instead of typing it in and compiling it. See if you can do this stuff on paper and then go ahead and put it into GCC and see if it works. But other than that, I'm not worried about people doing well on this, right? I think it's going to be pretty straightforward. So.
Is there any reason you need to know about for loops in Bash?
I will not ask you about for loops, no. I deliberately only do while loops because you can do a for loop with a while loop, and it's just more syntax to keep track of and stuff. So you're welcome to use them if you like for loops.
For is the best of the fields.
Yeah. All right, cool. Well, I will see you at 12:30 and 2:15, or I will see you next week.
And there's no the global variable.
I don't think you need to do anything with globals. All right, thanks. See you next time.